explain you. I'm trying to explain you what is happening behind the scene in the neural network, or with the perceptron. Because either you go for perceptron, neural network, same thing. The only difference is if you have single neuron, it's called perceptron. If you have lots of neurons, why we need lots of neuron, will explain you. One of the reasons would be auto feature selections. Okay, but logic will be same. Okay, so all those things I'm explaining you, if you know this, if you don't know this, if you understood, if you don't understood, right, you don't require, because neural network is so smart, right, they will do everything for you. You just tell what is your data, what is your x, what is your y, and that's all. And you just have to tell you want to do classification, or you would like to do the regress. They do everything for you behind the scene. Okay, so there's a beauty. But I thought, as a great data scientist, you should know everything, not only the vocabulary, you also should know what is happening behind the scene. So that is a reason I'm explaining you. And if you know what is happening behind the scene, right, so you know what, in the machine learning world, there is a journey of learning, or the path of the learning. You normally start with basic learning, Python, then NumPy, Pandas, visuals, then some basic, sklearn, then deep learning, neural network is a path. Okay, and normally when you reach the advanced path in this data science world, advanced path, there you will learn how to do tuning, how to optimize your model to have the perfect accuracy. I told you guys, I keep on telling you, in machine learning, whenever you train the model, they always give the output. Okay, and these two or three lines of code, just fit, create model, fit, and bricks, and that's all. So those guys who say I know the machine learning, and I can see the bricks, and my machine learning, and I normally is not good, but I normally laugh, right? I've seen lots of guys, they say I've created the machine learning model, and my machine learning model giving 89%, 99% accuracy. Okay, and I really appreciate how they are getting 99% accuracy. So I'm not challenging those guys, but when I got a chance to see the code, how they write the code, so it look like very childish. It doesn't consider anything. It doesn't consider anything. Okay, they just write the code, dump the data, and there's a concept called we'll discuss this concept after some time. It's called overfitting. It doesn't understand what is happening. Overfitting is there, and they don't know what is optimizer. Even though they don't know which optimizer to use. Okay, maybe they might use optimizer there by getting some code from internet, but they don't know. Should I use batch gradient descent? Should I use SGD? Should I use ADM? In the ADM, which parameter we have to use? Pass. Tons of things is there. Okay, so it's all vary upon data to data, your requirement to requirement. In here, if you go to classification, should I use ReLU or Sigmoid or threshold? What to use, right? Don't know. So finally, machine learning will give something. They don't know. Machine learning doesn't know, right? You are giving the wrong information, or you are giving the wrong process or wrong approach. So machine always do something for you. But what are you asking? If you're asking wrong thing, you're giving the wrong information, you're giving the wrong approach. They give the wrong accuracy, right? Or wrong accuracy means 99% would be wrong accuracy, because technically they are doing very different thing for you, and you're asking different things. So your prediction will be always wrong, right? So it's not about accuracy. It is about how you're getting the accuracy, your process right or not. that's the point, right? So that's the reason, guys, I'm explaining this thing very, very detailed internally. So when you create the machine learning model in the future, you should know what to use, when to use, when not to use, when to use ADAM, when to use SGD. We'll discuss about SGD and ADAM also, right? How much epochs you want, how to initialize the weight, maybe lots of things. Okay, even the Keras will do lots of things for you, but that is not optimized. That's not tuning. Tuning means you have to tune. You should know what is happening, and according to your requirement, a use case, you optimized by tuning. So it's a very advanced topic. My belief is, or my belief also, right? Because if you guys are giving lots of time and you guys are believing on me in ML ops trading, so I'm trying my best to cover each and every topic in machine learning world, especially in supervised and unsupervised learning. Okay, everything, either you know, either you don't know, either you ask me, either you don't ask me, because this is the something happen in the market sometime, right? If I say I will give you deep learning, in the deep learning there's no, there's no limitation, right? How much I'm giving, how much I'm giving you. Maybe I can skip some of the topic, maybe I can skip Adam also. Maybe I can skip this part also about discussing this concept, or maybe I can skip, this code I explained in the last class. I also try to explain today again. Maybe this one. So nobody can claim me that Vimal or Vimal sir, you missed something, you skipped something. Nobody can, because you don't know this might be also exist. So as a teacher, my responsibility and my duty is to train you in all the forms, and that's what my vision for ML ops class. You should be perfect in this world, right? That's my plan. Okay, so come to our main point, guys. This is some of the new concept I explain you, vocabulary I explain you. Good thing is, understanding this concept might be faster for you because you know the core concepts already for NumPy and sklearn. And that's the reason, guys, I was emphasizing a lot in sklearn and those concepts there, because if you know those concepts, learning the deep learning won't be big deal. And you also know some more concept of lots of kinds of feature selection. So when I go for deep neural network or neural networks, right? Because you know the feature selection concept, learning this guy again would be very simple. But I will explain this concept guys tomorrow. Not tomorrow, maybe after the break, right? But I would like to first take one practical example of this guy, of perceptron. So everything will be linked. I am taking this example in Togo. Okay, even though we don't require to know the machine learning, sorry, we don't require to know the tensor flow, right? Because we are not going to use tensor flow directly. Same way we don't use NumPy directly, we use sklearn. So here we use here we gonna use what you say, keras. But I feel, let's take one example again. So it will give you the internals, what is happening behind the scene. So it will help you in some way. So what I'm doing right now, right? I am taking the same example that I picked day before yesterday, and I believe after knowing all those things, you can very easily understood what is happening uh, in that particular tensor, for example. So what I mean by this, let me take this particular example so you can understand what I'm talking about, right? So the example that I pick would be again the same one. Let's take this example. Mm, let's take this example. Very simple. Let's take this example. What example I pick? Okay, take the same example, right? The we pick a day before yesterday. A lot of guys doesn't understood the example in that day before yesterday. But I think today you guys can understood logically what is happening. So again, I'm repeating. We are going to use keras for deep learning. Okay, what actually deep learning I discussed you yesterday, but I will discuss you again one more time. Before this, you have to understand neural network, and for this, you understood perceptron. What is perceptron? We discussed today in detail. And after showing the practical of perceptron, I'll explain you neural network. Even though neural network I explained you yesterday, but I would like to show you some more internals about the neural network. And if you understand neural network, obviously you will understood about what is deep learning. Okay, so what I'm taking, very simple example, very simple, right? Let's say we have collected one data set, or we collected one observation, and right now let's say we have only one single observation. Okay, and the observation that I have is I know something. For example, I know the x and I know the y, and let's say my x is 3 and y is 6. That I know. Same thing again, you can think this is your marks, and duration you study. And you also think guys your marks is only depend on one variable, it's called independent variable. So this is again guys the problem statement of your simple linear regression. Even though in the real world we never have simple linear regression, you guys know, but let's for make it simple understanding, let's start from here. Okay, so this is y and x, and if you draw this guy and with respect to what do you say, perceptron perspective. Okay, so you can design in this way. So right now you have a single x that is equals to 3. The single y that is 6, and because it is a regression problem, so we have to use some function like wx, something like this. We know y, we know x, but we don't know w. So how to find? Again, we use our mind or we use our neuron. So this would be our neuron. And as the neuron, and say neuron, we will feed forward x, okay, with some weight. Which weight? We don't know. This is the challenge we have. So neuron, our duty, okay, is to find the perfect weight. And how to find the perfect weight? You have to use some internal activation function. Which function? So you have to tell neurons what you want as output. It's a classification or regression. I say it's continuous. So they say, hey, it is a classification. Sorry, it is a regression. So you say, hey, it is a regression, or we know we have only one single feature. So my formula would be W. Let's for some time let's forget. So let's forget we don't have it. So just WX. This is my formula. Okay, and this is not actually my formula. The actual formula, what is the requirement neuron? This is my formula, but technically what they are looking for, error. So minimize the error, and where I want to reach 0. And for reaching the 0, right, one of the way would be, what can you do? You can wx minus y equals to 0. So you know x, you know y. If you find the y w, right, and we have to find this w, we don't know, right? If I multiply x and minus y, what we want to reach. So technically my activation formula is not wx. The actual activation formula is wx minus y. Okay, that's what this guy had to do. This guy has to do, right? For what? For finding the loss. Okay, and what his goal is, we have to minimize the loss, or try to take this loss nearby 0, maybe 0, if possible. Okay, but for this, they will take the y, they will take the x, and do the things. So guys, this again what? This is again one single neurons we are using. Okay, y1 right now, obviously, because you have one feature, so more than one we can't do. But when we have more than one neurons, there will be a neural network. Would be the second main example. So if you want to do this, either you can use keras. So we'll use keras for some complex example. But right now I'm using TensorFlow, the same TensorFlow that we use. So again, I'm going to this example. So I'm loading the TensorFlow over here, and in the TensorFlow, what I'm doing, I'll say TensorFlow. My x is always fixed. Obviously, the past data you can't change the duration remarks. So my x is a constant. It's a constant. It is what? It is 3. I'm repeating this example again because now after doing this today, you will understand. So there are 2 constants I have, x and y. But thing that you don't know, but what you do, initially you take a random value. What random value? Anything. In my case, I am taking the random value, for example, 20. But it's keep on changing. Because w is keep on changing, so I want w to be variable. Let's say 20. And because in the mathematical operation, they normally they do operation in decimals or float. So it's good practice to pick the float. There will no data type issues come up. Okay. Now what I want, right? I'm telling my neuron this W is the initial I have found. So technically 20 if I multiply with x is 3 minus y is what 6 is what 50 60 minus 6 is what 54. So what is 54? Is my loss. That is equals to 0. No. Okay. So we know our actual value. Let's think in this way, right? If you multiply W into X, you get 60, and my actual value was 6. So right now my formula is giving me 60, and actual value is 6. It's very far. So what we have to do? We have to minimize the weight. You have to minimize the weight. Okay, because it is far from 60. Or you're positive, if you minus it. The loss is positive, right? So what do we have to do? We have to minimize it. So we have to descend, but descend at the descend in the lower direction. And how we come to lower if we minimize the weight? Okay, that's what we know. But right now my weight is 20, right? I would like to descend. How much? 18, 20, 18, 1, 5, what? Let's say 15. So how I know I have to descend 5? We don't know, right? So here the role of optimizer comes. And one of typical optimizer and very basic simple optimizer is called gradient descent. Right? So that's what I'm going to use here. We don't use gradient descent or basic gradient descent in the real world, but this example is showing to just give you the high level idea. So there is a TF guys, and in TensorFlow we have a function called gradient descent tap. TAP function is a function, or this function guys normally you can think this function as a linear regression function, something like this, and we always storing some variable like for example t, and then we use t for doing something. Okay, but here guys, after you use this function, you can think this function is like your video capture. So what do? You first do a video capture, click the video, and what you do in last, you close your video camera. So first you start the camera, then you close the camera, and between start and close, you click the photograph. So if you have a requirement something like this in Python, the first you have to start your camera, then do something, then close the camera. So starting close you can do in one single go. So there is one keyword called with. Okay. So what with will do, they will start this function, then they do something, and afterward they automatically close it for you. So you don't have to close it. And this function you have to store in some variable, for example, let's say tap variable. You can give this variable name anything. Like in the camera, we have given the variable called cap variable. You can give any variable. But don't worry guys about with. We will discuss more about with. It's a Python keyword, right? When we go for Python, I'll discuss there. Okay. Now what I'm saying, I'll telling my TF that this is the activation function I need. What is this function? This is a linear. Okay. So running this function in TensorFlow, we have mathematical operation, and I tell this guy that I have to use this function. Function is what? W multiply with x minus y. That's all right. So what my gradient descent will do? So what my TensorFlow will do? They run this function, and after they run, what they find? They find loss. And the loss is high. What the loss would be? They will do descent. And what to do? They change the value of W. First their value is W is 20. They adjust to 50. And for adjustment, they have to go down or maybe go up. How much? I don't know. Because I don't know, that is a reason we have to use optimizer. And here my optimizer is who will find how to go, how much go down, right? Is known as gradient function. So this is a function that tell me how much you go down. But for this, right now initial weight is 20. Now you have to go down. to 5. Okay, how the guys know go down, how much go down? Okay, so you tell your gradient descent your loss, how much loss you're getting. Okay, and how much loss you're getting, this guy will tell you. So you store this variable in loss function, or sorry, loss variable. So this one function will tell, okay, this much loss I have. If you don't have any loss, obviously gradient descent won't go down or go up. But if you have a loss, gradient descent will use some internal method algorithm to go up and down. So you have to pass loss function. Not loss function, is a loss variable. And you can think, even though this is a normal mathematics, but you can think this is called loss function. So you can let me write a comment here. So the line that I write here is actually loss or the post function. Okay, this is my loss or the post function. And if I have any loss, they will store it. Because if you have the loss, only if you have the loss, then gradient descent is my what? Is my optimizer. What they do? They descend. Or means they change weight. Okay, either increase or decrease. Initially my weight was 20, either they go to 15 or they go to 25, or they go to 21 or 19. Depend my loss is positive or negative, whatever they have, they go down and up. Okay, but in the gradient descent you tell two things. What is my loss? And if you have a loss, which value have to go up and down? Obviously guys, we have to adjust the value W, either increase or decrease. So W we have to adjust. So tell my gradient function, we have to adjust W. So gradient descent, gradient is a function here. It is my optimizer. Very basic. We don't use this, but this logic is very interesting. This give you what is happening behind this. So we have to do up and down this value. So if you keep on having the loss, we keep on doing descent in the weight. If the loss is 0, if we will, we don't change the weight, we don't adjust the weight. Okay. And one more thing, guys, I told you initial classes, right? When you talk about loss is always absolute value. For example, your real value is maybe real value is 50 and your prediction is 55. So if this is your loss, for example, 55 minus 50 is what? 5. But maybe your real is 50 and loss is 45. So 45 minus 50 is what? It's minus 5. But loss is loss. For example, if you talk about the graph, if this is your real value, and system either predict this one or system predict this one, right? But technically, according to your line or prediction line, right, you can see this difference. This is the distance you have. So either your distance up 5 or go down 5. The distance is or loss is always 5. So loss is technically, I explained already, is always absolute. And absolute minus 5 is what? 5. So whenever you consider the loss, right, we never say my loss is minus 5 or loss is 5. Or loss is always not like minus or positive. Loss is always 5. And this is, guys, when you talk about the initial loss function, if you remember, I use MAE, absolute. Or if I go for SC also, S is square. And when you do square of negative, again it comes positive. So loss never be negative. It's always a positive number. The only thing is we would like to minimize the loss and try to least reach till 0. That's what our goal is. So that's what I will do here. I will do an absolute of this. So there is a function called ABS. It's called absolute. So whatever value will come up here, they take the absolute, make it positive. That will be my loss. And the loss is not equal to 0. They keep on just the weight. They keep on doing.
हेलो
हाँ जी,
क्या सब्जी का खा रहे हो?
पता नहीं।
पता नहीं मतलब
आप चिकन नहीं ला रहे?
यार अभी तो आ रहा, चिकन कहाँ मिलेगा इस टाइम, बनाएंगे कैसे बता?
अच्छा, मम्मी
रेडीमेड मंगवा, बिरयानी मंगवा लेना तू।
पापा पूछ रहे खाने में क्या है?
वो दाल और खीर है।
आलू मटर पनीर है और दाल है और अंडे बन जाएंगे, बहुत है।
हाँ
आलू मटर पनीर दाल और अंडे बन जाएंगे।
अंडे कहाँ पे है?
अंडे हैं? नहीं है, अंडे भी नहीं है। आ
अंडे है ही
जाएंगे।
नहीं अंडे।
अंडे ले आऊंगा, खाने तो बताओ। ठीक है,
नहीं तो मैं ट्रे लेता हूँ आते हुए।
चलो आप ले आओ अगर मिलती है तो, नहीं तो मैं ले आऊंगा।
चल मैं आते हुए ले आऊंगा,
ठीक
देखता हूँ।
ठीक।
यार मेरे पास ना टर्बो है यार, स्कूटी पे कैसे लाऊं?
कोई नहीं, चलो मैं।
हम कहाँ से निकलेंगे? गाड़ी मोड़ कर देना।
चलो ठीक है, बाय।
चल ठीक है, मैं
क्लास में।
देखता हूँ, लाऊंगा अपने आप, देखता हूँ। और सामान तो गाड़ी का ना।
So this is guys, this function will give you how much you descend next time. So let me store this guy in one variable called dx, or maybe you can use a descent, for example. So you can, let's say dx is a very common variable we use. It's a variable name. Okay. So and finally, when this function give you a loss, it go to my daily descent and say, because we are having the loss, change the weight. How much change? 2, 5, we don't know. This one. Or because we are changing, so my initial weight was 20. Now what is the new weight? So DX say your new weight will be minus 5. So you do minus with the new weight. Minus. So your initial value of weight is 20. 20. And descent is dx here is 5. So what is the new weight? Obviously w minus dx is what 50. That's what I want. So that's what I'm doing here, right? So what I'm doing, right? I'm assigning w. Okay, in the TensorFlow, if you want to assign new value, this is the way we assign. I told you in the TensorFlow. So what is the value of this guy? Is 20 minus, for example, let's say 5. Okay, 5 from here. 50. And 15 I'm assigning where? Here. W. Or because we keep on changing w value, this is the we assign the variable. That's all, guys. So when you run this function, when you run this part, right? What this will do for you? It will find the loss, and because you are having the loss, this optimizer will give you this descent and new w value come up. Initial 20, that's a randomly, but next value would be what? Would be 50. And if you want to just check how about these guys, so you can use print, and I would have to print the value of new w. I will have to print the value of my dx also. I will have to print the value of my loss also. 3 value I'm printing. In the Python, you're going to print multiple variables. You can use comma and make it more better. You can say just print one string. My weight is w. My descent is comma dx, and my loss is this guy. You want to print? Yeah, you can print it right now. So as soon as I run this guy code, okay, what you got? Right? What you got? Initial weight. When I run first time this gradient descent function, okay, my weight is what? 70. It means what my optimizer found is very interesting example. What my optimizer find, they say initialize you as initial weight 20. That's what your choice, random. But what I found, you have to go down to 70. This would be a new weight. This is called adjusted weight. And why I go down to 20? Because I found my descent is 3. If you see guys here, the descent they found, where it is? The descent they found is what? 3. Okay, because this is 3, so new weight will be what? 70. And guys, this is actually whenever I print any variable in TensorFlow, they print in this way. But you just want to print a value, so TensorFlow internally stored into NumPy. So you just want to print a value. The W is my complete tensor. So numpy you can use to print only value, so it will be more clear. Okay, so let me run one more time here. Let's take from starting. The value has been changed. Okay, now it's so interesting. You know what? I'm just trying to show you. You know, I'm very excited because whenever you use Keras and all those sklearn, they show you final output or your final weight, and we are very happy they give the final weight, final bias, final coefficient, final predictions model. But what is happening behind the scene internal algorithm? All right, they never give you. Normally they never give you. So that's what I'm trying to show you what internally happening. So my initial weight was 20. Because of 20, I had a loss 54. It's very, 54 is big, right? My loss should be 0. Because my loss is very big, so gradient doesn't say loss is big. So I'm finding new value of W. And for the new value of W, you have to descend what? 3. Or because your initial value is 20, you have to descend 3. The final value of what weight will be what? 70. Okay. Now what I'll do? Again I'll do what? According to this diagram. Okay. So I first feed forward. I reach here. They say big loss. What to do? Back propagation. And what we do in the back propagation? Find the new weight. So this code, guys, this code is all about back propagation. Okay, they find the new weight. Then what you do? You again feed forward and find the new loss. How? I again write this code. Because my new W is what? 17. If I run this code again, what do they find? They find initially, if I draw in the diagram, initially your loss was 54 when you had a weight 20. Now your weight is 17, your loss is what? 45. You want to minimize loss, you want this is our goal, to minimize the loss. What you have to do? Again you have to descend. And next descent would be again what? 3 only. And final weight, next weight would be what? 14. And when you have weight 14, let's see what would be. I'm again running again. My W value will change. Click. Now loss is 36. It's decreasing, it's good, right? And now next weight is what? 11. Let me run one more time. You weight become 27. So loss become 27. It's good. We are reaching to 0. This is 0 here. And now the next weight would be what? 8. Again we're hitting. Next loss is 18. And weight is what? 5. Weight is also goes down. It doesn't matter if it goes down. My main concern is loss. Again I'm running this code. Loss is 9. Good. Again I'm running this code. Wow, this is loss is 0. So finally I do something and I reach 0 or maybe near to 0. This is very common basic example. In the real world you never go to 0, that you guys know. But I reach 0. Okay. So you know what I keep on doing? I keep on feeding new weight, and you know this part that you keep on feeding new weight. Okay, it is also, you can say, this called feed forward. You are feed forwarding again and again. This part. After feed forward, you got the loss, and because you got the loss, you find the loss. So you find the next gradient. Change the weight. Again feed forward. This complete process is known as back progression. So feed forward is also a part of back progression. So feed X and Y with weight, find the descent, change the weight. Again go, again feed. This complete one loop is called back propagation. And in my case, guys, I have done I think 4 or 5 or 6 times. 6 times I have done back propagation, and finally what we reach, will we reach our goal, loss is 0. But when I find loss is 0, when we find a perfect weight, and my perfect weight that I found is 2. 2 is my perfect weight. And they learn from where? They learn from these two guys. They learn from these two guys. Okay, and these two guys what? It is just my one observation. Just one observation. First observation. And first observation say weight should be 2. But we don't know about second observation, right? I'll for example, let's pick one more observation. How? Let's say, okay, my second observation, my value is 4, and my second observation number y is, let's say, 8. Okay, and again I run my code. They say yes, 2 is perfect. Okay, because obviously 2 into 4 is what, 8. But if I feed one more x, where x is 5, and where y is, let's say, maybe 15. Okay, I'm not changing the weight here. And now what they do, they say no, we have to do -5 descent. Guys, you see they're doing -5, negative descent. Loss is 5. Again they do one more time, they say loss is 20. Okay, and you do one more time. So they're moving between the direction. Okay, that direction only. Up, down, up, down. So either you go for weight 7 or 2-7. But if you go to weight 2, you have 20 loss. If you all the observation, and finally what observation come up is become one epoch. And then you again do epoch, right? So this is just one type of progression only for one observation. Okay, in one observation you have to run this hundreds and thousands times maybe, right? Then one observation complete, then second, third, then you have thousands of record, you have to run thousands of times. This code one block. Again, thing is so computational oriented code, right? And guys, believe me, this is very powerful code. Even though we're not gonna use this code for any time, right? We're not gonna use this, okay? But I believe if you really want to understand what is feed forward, what is actually loss, you want to understand what is optimizer, what is descent, why optimizer need loss in the weight, and how to keep on adjusting the weight, and the goal of descent function is to reach minimum or minimize error. Okay, this is a perfect example to see. But if you go for a scalar or Keras kind of tool, you can't get it, right? So I thought to explain this code in very logical form, but I've never seen normally in deep learning, right? Somebody explain you internal this kind of code. So it isn't like about the internal or the core or a complex thing. It's about to understand the logical things, right? If you understand logical thing, now whether you can use PyTorch or TensorFlow, it doesn't matter. Logic is same for everybody. But yeah, we don't gonna use this. We are going to use Keras. Keras makes this thing very simple. Whatever I write here, big code, right? And it's not about only one code. Finally, you have to write this code in a loop, and loop will keep on changing the weight. It becomes one observation complete. And if you have 1,000 observations, so you write one more loop that will go to all 1,000 observations. 1,000 observations. One epoch complete. and you have to do again this epoch 100 times. They have to write one more code, one more loop outside this to run this, right? So all those things, this code again loop and loop and loop. I keep on changing the weight, keep on getting the multiple observation. This complete code, what I discussed with you in extra loop, can be done by Keras in one single line. One single line they have created a code, and one single line everything will done for us. So you don't have to go and write this code of TensorFlow behind the scene. And that's is the reason Keras is known as the front end of TensorFlow. So TensorFlow is back end, but Keras is known as front end. And say you have to deal with Keras and say I want this. Keras will go behind the TensorFlow context. They write this code, they run this code for you, something like a more complex code, and they give the output to you. But what is Keras will doing for you? I just trying to explain. So this is the one great example. I think in the last class I tried to explain you. Maybe it was a little bit complex, but now I think you guys understood what is happening behind the scene. Don't focus more on width. Okay, we'll discuss in the Python class about width, but technically width it will start this function, then they run all this code, and after running all this code, they close this function. So it is something that they start video capture, like in computer vision. They click the photograph, and finally they close the camera. So you can think in this way. So don't focus more on width. We'll discuss. Okay. So one great concept I explain you. Now guys, I'm not going to use TensorFlow for that. Maybe some example I show you maybe in the future, but we don't require right now. Next, I'm moving to the Keras. Okay, I have some one real example with me. Okay, and I'll use Keras to do it. But this example, guys, what I'll show you, it is one neuron. And if you talk about where is neuron, so this part is your neuron. Only this part, not this part. This part. What am I highlighting here? This is the duty of the neuron. Neuron, they are doing for you. And what this inside the neuron? This is the activation function that the neuron is running. Okay, so this is a linear activation function, I say. Okay, but you will have some sigmoid other function that we used in the classification, but you have to just change this function, that's all. Otherwise everything would be something like this. Right, so it is something like this. So lots of internal concept I explain you. Let's take one quick break, and then after the break there is one great example. I would like to start Keras, and same Keras will take it forward for the remaining classes. So again guys, take 15 minutes of Q&A, and then 25 minutes of break. So we will resume our classes at 9:25, but I'm still here. Any queries you have, you can post here. What is epoch means? Thank you, Fulguni. What is epoch mean? Epoch, I told you multiple time you keep on loop. I explain you 2 or 3 times, but don't worry. When I go for Keras, I show you their epoch mean. So it is very visible there how epoching is doing. Okay, what is epoch? So back propagation multiple times of each operation for all available. Yes. Back propagation we do multiple time per observation, right? So right now what I have done here, I had only one single observation over here. This 1x or 1y. Okay, but I keep on running this code multiple times till the time I got the minimum loss. How much I run there? 4, 5, 6 times I run. Every time my losses keep on goes down, and when loss goes down, my weight is also goes down. So this I had done for one observation. Okay, so in one observation you have to do back propagation multiple times till you get the minimum loss. Okay, but if after you go to second observation, and whatever final weight you reach, you apply in the second observation. Again, second observation, maybe this weight doesn't support, doesn't give you loss equals 0. Again, adjust the weight, go to third and fourth and fifth, keep on goes down, and where you reach, last observation. And this complete from first to last are known as one epoch. One epoch. Subham, in basic example, you can run in your hardware. You can run in the hardware, it won't give you impact. But if you have huge data, I have other solution for you guys. I will share with you tomorrow and after tomorrow class. So whatever code we are running right now, very basic data, you can run your laptop for practice. But further data, I'll share some other way for you guys. If you have multiple X in single observation, how we going to do this? Yes, Ram, here it would be a little bit complex. We have to use a function called W1 x1 multiplied W2 x2 multiplied W3 minus y. We can do the same way, right? The same way here, but it may sometimes complex, and that is the reason we have to go for Keras. Keras make this thing simple, right? But here the formula would be W1 multiplied x1 plus W2 multiplied x2 minus y. So this kind of linear function you can use. You can try it; it will work for you in the same example. But in the Keras, it will be simpler to use. Yes, Rohan will definitely learn classifier. Don't worry. When you start, you'll see it was very simple. So my focus here is about to go show you those core concepts. Otherwise, after knowing this, learning new module or model won't be big deal. Mark your note from today's class, previous class. Okay. In feature elimination part, why we need one constant column in the predictor data set in the OLS. Okay. Because you know what, we also want to know, does we have to use bias or not? Because constant that I add, constant would be the weight of your bias. Okay. And our requirement is, if you would like to predict y, do you need bias or not? If you remember in the first example, when I started about marks and duration, that time bias was 0. How we know? And we don't use bias. Even in the same example also, I haven't used bias. So how I know I should have used bias or not, or should I eliminate the bias or not? Here the example was very simple. So we know if a matter 4-bit 2 is comma 8. So, but in the complex example, we don't know we should use bias or not. So OLS help us with the help of p-value, should we use bias or not? Okay. So this is reason for including the bias. We add, because bias doesn't has a weight. So this is reason bias weight is by default 1. So I add 1 as a constant. Facing some issue while importing TensorFlow, module not found, but install in the new environment. Yes, you can install in new environment. Don't worry, guys. I told you already. Don't install TensorFlow in our current base. Create a new environment and install the TensorFlow there. That's what I'm doing here. Okay. I understand that loss, DL or error, EN is same. Then how the gradient method figure out it has descent or ascent to get the closest perfect weight when error is positive or absolute? No, actually, you know what, Sandeep? At time of finding loss, right, we make it absolute. Internally, you know what? They use they know the loss, right? Even though we change it to to what, to absolute, but I know my initial loss was 54. Now after I just find a new loss, it become 45. So obviously they know it have to go a descent. Okay, so this is the way we have to make it minus or plus. Okay, because we know the old loss, now we know the new loss. So obviously they know we have to descend. Okay, I understand your point is, so this reason that this gradient descent is not perfect optimizer. In some cases exception it not work, I agree, So we don't use this gradient optimizer, right? Either we use ADM, or maybe use SGD. So we'll discuss further about those that are more optimized, more better, and more perfect. So I'm not saying, guys, this gradient descent is a perfect optimizer. Okay, this is a simplest example, so I show you, but it won't work in all the environment. But other gradient descent we have, so yeah, other optimizer we have, the logic will be different, but use is same. They are perfect. So I think Shivam, I already explained epoch, but don't worry, guys, if you doesn't understand the epoch. So um, when I take the today's Keras example, first one, you will link it very easily. Okay. Can we tell me more about decorator? I'll try simple. If I can take the decorator class in Python, I'll try definitely. But my next plan in the Python class to take lambdas and methods and some other concepts. Can we try to tuning optimize model in the tuning? Yes, Sonali, we will. I'll also try to take you guys to that level to tune and optimize your model in at the higher level. We keep on moving that direction. But right now, I have to explain the core concepts. Does we say neurons are just like a model? Um, uh, yes, you can say right now. All right, neurons is just like a model. Initially, the model is empty. They don't know the value of W. After learning, they know the value of W. So yes, you can say a neuron is a model. Okay. Initially, neurons is help you to train to find the value, and after same neuron we can use for the prediction. So yeah, you can say Premchand, neurons is like a model.